Okay, so I'm going to go over the preview so that we have to study for the test that's coming up this coming Wednesday, Thursday. It got pushed back because of the ice days. So you want to solve each problem and show all your relevant work. Make sure you adhere to the criteria for credit and attach your work to the exam. Work must be shown in order to receive credit. So this test is going to cover the special segments, points of concurrency, and then a review over triangle congruence. Okay, so for objective 1, it says which segment is the median. And we went over the median on day 3. The median is connecting the vertex to the midpoint of the opposite side. Okay, so if I look at angle J, that's a vertex, or point J is a vertex, and I look at the opposite side to B, do I see that's a midpoint? No, I do not see any markings that B is a midpoint. So then I'm going to go to K. If I look at K and go to C, do I see C as the midpoint? No, so that's not the median. If I go to point L and I look over at point A, I do see tick marks indicating congruency, and that means that A is the midpoint. So my median is going to be segment AL. Number 2, which segment is an altitude? An altitude goes from the vertex perpendicular to the side. So what I'm looking for is this little square right here. That's the only one on there. And since I know an altitude has to be perpendicular, KC has to be my altitude. The circumcenter is the same distance from the vertex. That is in your graphic organizer. It is in the important facts under circumcenter. The incenter is the same distance from the side. Again, that is in your graphic organizer underneath the important facts. Okay, we're going to move on to points of concurrency. Points of concurrency, that is where all of our special segments intersect at. So for the perpendicular bisectors, that's the circumcenter. For the angle bisectors, that's the incenter. For all of the medians, that's the centroid. And for all of the altitudes, that's the orthocenter. Okay, so what is XZ? Okay, well, this is an angle being bisected. And we had that angle bisector theorem that said if you had a point on the angle bisector, then it was equidistant to the side. So since these 90-degree angles here indicate the shortest distance to the side, that means that these two pieces at 7h minus 5 and 3h plus 5 are congruent. They're the same distance away from the side of the angle. So that means I'm going to have, and I'm going to erase that so I can see my number. That means 7h minus 5 is going to equal 3h plus 5. And then it becomes an algebra equation, and we just solve for h. So I like to take my smaller h over. So since 3 is smaller than 7, I'm going to subtract 3h from both sides. Combining like terms, I get 4h minus 5 equals, my 3's go to 0, plus 5. Now I'm going to move that negative 5 over by adding 5. And 4h is equal to 10. I'm going to move on over. 4h is equal to 10, which means I need to divide by 4. And h is equal to 10 over 4, which reduces to 5 over 2. And decimal-wise is 2.5. So either one of these two answers would be acceptable. Number 6, is segment QT a median, mid-segment, altitude, angle bisector, or perpendicular bisector, or neither? We didn't really go over mid-segment, so we can eliminate that one. QT. Okay, well, I see QT here. I highlighted in green. Okay, I also see that it has markings of congruency, which makes Q a midpoint. We had two that had a midpoint, and that was the median and the perpendicular bisector. Okay, well, it's easy to discern between the two because I don't see a 90-degree mark, so that means it's not perpendicular. So this is a median. Now it asks, how do I know? Well, I talked through it as I went through. So how do I know QT intersects side RP at the midpoint? And let's see, is there anything else I can add? I guess I could say QT is a vertex to a midpoint. That's technically the definition of a median. Okay, so how do I know? Well, I talked through it. I know it's not a perpendicular bisector because I don't have the 90-degree angle. You could say that. I know that medians and perpendicular bisectors are the only ones that meet at the midpoint. You could say that. So there are lots of different ways you could say it. Okay, now I'm going to go on to problems 7 and 8. What is the measure of RV? Here's RV, highlighting it in green. And it says PS is 12. Okay, that's one median. UV is 2.7. I think I need that one. So there's 2.7. And ST is 7.3. Don't really think that's going to help me find RV. Now, if you'll remember from previous videos and in class, this median, okay, from R to U is the whole. And our property of centroids, which is what this would be, tells me that this piece right here is 2/3 of the entire length, which makes 2.7 1/3 of the entire length. Furthermore, if we look at part to whole, this takes up 2 of the parts of the segment, this takes up 1 of the part, and that's associated with our numerators. So if 2.7 is equal to 1 part, then RV, which is 2 of those parts, equals 2 times 2.7, which is 5.4. Okay, that's if you see it from the perspective of part, whole. Now, we could do it algebraically, just like we did in our example in class, because I know 2.7 is 1/3 of RU, the entire length. And just like we did in our example in class, I would have to multiply both sides by 3 to eliminate the 1/3. The entire length is 8.1. And again, I know that RV is going to be 2/3 of that 8.1. Okay? So since RV is 2/3 of that 8.1, I know 3 goes into 8.1 2.7 times, and 2 times 2.7 also gives me 5.4. Option 3. If I already know that the whole length is 8.1 and one part is 2.7, then the second part is going to have to be 5.4. Okay, so there's 3 different options here. We could go with part to whole. That's one perspective. We can do it algebraically. And then we can do the sum of the parts. So we have multiple options to find our answer with this problem. What is the orthocenter of triangle ABC? Okay, well, for point A, I need to draw the perpendicular to the opposite side, which is going to be BC. And what I can see right here is that AB is going to be that perpendicular line because it's already perpendicular. If I go to point B and I draw a perpendicular to the opposite side, which is AC, that one is slanted. So I will need to find the slope of AC. So I'm going to count. I'm going down 1, 2, 3, 4, 5, down 5, and over 1, 2, 3, 4, 5, 6, 7. So my slope is negative 5 over 7. Not sure why I wrote 2. Oh no! Wrong button. Okay, negative 5 over 7, which means my slope perpendicular to that one is going to be positive 7 over 5. So I'm going to have to go up positive 7. 1, 2, 3, 4, 5, 6. Ooh, I don't have enough room. 7 and over 1, 2, 3, 4, 5. It would roughly be right about there off my page. I guess I could do half. I could do 1, 2, 3 and a half and over 1, 2 and a half. That would put it right in the middle of that one. And I could draw my altitude. Okay, it still crosses at B. And then we have point C that would go to the opposite side, AB. And it's already perpendicular here at B. So all 3 of my points intersect at point B. So my orthocenter is point B, which is 4, 2. Now remember in class I said if the orthocenter is on the triangle, that means it's a right triangle. Okay, our next section. Okay, we covered this on our Frosty Day relay as part of our review, but they're congruent triangles. Are they congruent by side, 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 angle, angle, side, angle, 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 side, hypotenuse, leg, or none? So I'm going to look and I see I have a side, an angle, because that right angle counts, and a side. And I want to check. Do I have a side, angle, side here? Yes. So number 1 is side, angle, side. Number 2, I only have 2 markings, and I need at least 3 based up here. So I have to remember I have to mark my vertical angles. So these count. Now I have an angle, and a side. I have to check the other one. Angle, angle, side. So yes, these are congruent by angle, angle, side. Then I have my third triangle, and again, just like I have vertical angles here, I see a reflexive side in the middle. So I'm going to go ahead and mark those. And now check, because now I have angle, side, angle, and check the other side. This is an angle, side, angle, and these are congruent by angle, side, angle. Okay, so that's our blast from the past and triangle congruency that we had before the break.